Is everyone having a good morning? Yes? Yeah. Is everyone having a good morning? Yes? Yeah. Oh, God. All right. I'm going to feed off of your energy. So if your energy is terrible, this is going to be terrible. So what we're going to talk about is a little presentation. It's called The Assurance of Quality. Otherwise known, of course, as the never-ending story or Mission Impossible. So quality assurance is a large area of knowledge as an introduction. Although most of you often think of it as perhaps a job title, part of what this discussion is really to say, it's kind of like software engineering is actually a field of knowledge, and someone can be a software engineer. Quite a different sort of way to think about it. So that's kind of the overall arching theme of what this presentation is, to say, when we talk about quality assurance, in the context of software or in the context of other things, what does it mean and what doesn't it mean? Who does it affect and who doesn't it affect? I went to the internet and I got as many good pictures and GIFs and stuff, so this should look like about a 1996 PowerPoint presentation, I'm hoping. So I hope you enjoy it. There's nothing too serious about it. So what we're going to talk about over lunch today. We're going to do a 40-minute, I underline, highlight, informal presentation, a Q&A afterwards for about 10 minutes. So at the very longest, we'll be here. I'm hoping to actually be done here at the very latest by 12:50. But it could be much shorter, it could be much longer. Depends on you, depends on how the presentation goes. So it's up to the group. We're going to talk about the big question, which is, what is quality? That's really, it's actually a really big question. We're going to talk about what is quality assurance and what it isn't. We're going to talk about what does a software quality assurance team member do, how does that fit into the larger latitude picture, a little question and answers. I have a beautiful picture here, why you know fix all debugs. So for anybody who's missing that. So let's explore this topic together. Okay, pause. It's lunchtime, deep breath, right? Nothing else to think about but quality. Okay, so look at your neighbors, look to your left, look to your right, smile. Let's enjoy our lunch. And here we go. So what is quality? Whenever you're going to do a presentation, whenever you're in doubt, what you should always do is go to some authoritative source and randomly pick something so you look smart. So what I did is I went to the dictionary like every other speaker does when they do something like this. Say, what is quality? And what I did is I said, well, I looked at quality has, the word quality has distinct definitions. The peculiar and essential character, something's nature, okay? So her ethereal quality. A degree of excellence, a grade, the quality, for example, of a competing air service. A social status, a rank or a ranking, best in class, queen of the prom. A distinguishing attribute, which is a characteristic, possesses many fine qualities. Character in a logical proposition of being affirmative or negative. And weird definition, a vividness of hue. I thought that was kind of actually really interesting, a gradient. The identifying character of a vowel sound determined chiefly by the resonance of the vocal chambers in uttering it. I don't know what that meant. The attribute of an elementary sensation that makes it fundamentally unlike any other sensation, which is, again, quite interesting. So the key question here is, how many spelling errors are on this page? How many? Okay, so let's if I had money on this, I guess I could offer a reward, but so it's a good question. So let's go for who says there's more than 2? Hands up. Okay, more than 3. More than 4, more than 5, more than 6, 7, 8, 9, 10, 11, okay. So I intentionally injected 9 errors on this page because I thought that would be interesting to see, well, I'm yammering and talking up here and people are actually ignoring what I'm saying and just reading my PowerPoint presentation. When would they notice the first error? And usually you can tell by people start to giggle, right? They're like, that guy doesn't know how to use spell check, what an idiot, right? Like he's doing a presentation for the whole company, he didn't even look at the spelling, right? These are important things. we want to talk about quality from this perspective because this is how our customers often see our products, right? They're just looking and using, they don't know what I meant to say, they just know what I said. So when I'm typing or writing something here, I've got these spelling errors, it might have a negative perception that you have of me. Like I'm not smart enough to use spell check, right? Or you might not have noticed, so like here's a funny one if you didn't see this one. The word quality has 8 distinct definitions. Right? I threw that one in there as the first one because it's actually not a spelling error. It's the use of the wrong word in the wrong context. So it's grammatically correct. It's syntactically wrong. But it's interesting, right? When we talk about quality. So I have more examples of this, but let's move on. The next thing is, so I decided to pick 2 things that I kind of felt of those definitions that really talk more about engineering quality or software quality. Quality is a degree of excellence. That's one of the definitions I chose. Okay, so it's kind of like, for example, here, product grade. You have grade A eggs, grade B eggs. Most people never buy them. Grade C eggs. Right? Most people have grade A. You hear grade A eggs. What does that mean? Well, they're actually something that is measurable. Right? There's a measurement system. It's not arbitrary. Right? It's not like, oh yeah, my eggs are grade A. It's like, no, an external body goes out, they have a characteristic for something to do with color, maybe the internal color of the egg or from the breed of chicken. There's a grade, it's an outside source. Some of the things we might talk about with grade in software, the best software in its class. Right? You often hear that. It's the best software in its class. It's not the best software, just best in its class. Right? So maybe a particular knowledge area. It's the most downloaded plugin for Chrome. Wow. Like, does that mean quality? I don't know, but it is something that you might measure. It's externally met a standard. So in the healthcare space, I did a contract not long ago, but we talk about it in the American space, something, a medical record might be talking about being HIPAA compliant, right? So it's the idea that our software meets an external vendor's sense of what is a version of quality. The other kind of definition I'm playing with today is quality as a list of distinguishing attributes. Okay, so these 2 things often kind of get blurred in people's mind. We use the word quality in lots of different ways. So we're talking about software quality. We want to be a little bit more narrow in how we're talking. So, for example, a distinguishing characteristic. The software runs quickly. The interface is user-friendly. So not necessarily quantifiable, but it is a characteristic that we're trying to describe. The software is platform agnostic. Again, it's a good quality. It just might not be too specific. Like of all the platforms, there's no tie to them. It's hard to say. Another one would be the qualities of a great leader. So I just threw a bunch of things in there: learner, expressive, problem solver, adaptive. So we're going to do a lunch vote first. We're going to take a little pause. Okay. So we're going to start with my beautiful pictures here. So here's a beautiful flying rainbow cat. I like lunch, and I like even more free lunch. And I love a good free lunch. So what do you think about the lunch today? Pretty good? Okay, we're going to thumb vote about the lunch. So up for good, sideways for okay, and down for not that good. Okay, and no one's going to take it personally here. Just tell me a little assessment of what you think about the lunch. On the count of 3, 1, 2, 3, thumb vote. Okay, so I'm going to take a wild guess here. We're looking at about 60% good, 20% sideways, and a bunch of people say, I'm not doing this. Okay. So we're going to talk about software quality by analogy, just for a minute. A little sidebar to take our minds from other things that we know, if software quality is not our thing. We're going to say, but we all know about quality. So let's talk about what is quality. So you're all currently eating food created and prepared by someone else. Okay? Much like the software products that we use. Most of you have no idea who provided this sandwich. Who knows where we got the sandwich today? Hands up. Okay, very small group of people. Now, of the people that actually know where we got the sandwich, how many of you know the history of the company? Okay, so now we've gone to about 3 or 4. And of those, how many of you know the status of the company with the local health authority for food poisoning outbreaks? Okay, so on the other side of it, likely most of you who are currently enjoying the sandwich, which I'm going to eat right after, you didn't ask for a list of ingredients, unless perhaps you had a dietary preference, gluten or vegan. But most of you are like, I don't care, I'll just eat whatever. Delicious, right? And most of you didn't ask for a list of components that went into the ingredients. Like, what went into that sausage in the sandwich? What went into the roast beef? Is it a GMO? What is it? Everyone's like, I don't care. I just got to get that sandwich, right? So let's take the food vote again. So who thinks it was a good sandwich? Thumbs up. Okay sandwich, sideways, and thumbs down. 1, 2, 3. Okay. Slight change in the vote, but not dramatic. Okay, so let's move on. Deaths caused by foodborne illnesses. So yes, I am coming back to software, I promise you. But now I'm fear-mongering, so let's do this. In the United States, a population, just over 10 times our size, an estimated 48 million, that's a lot, foodborne illnesses occur each year. There are more than 250 pathogens and toxins that are known to cause foodborne illness. Many of them almost all of them, can cause an outbreak, right? I love movies like that. Sources of contamination. And I'm coming back to software. Just bear with me 2 minutes. All the components of your sandwich came together, of course, from many sources, right? All of us have seen this at some stage of our life. It kind of comes into our mind and then it goes out of our mind. So we start up here at the farm, we go to manufacturing, we have some transport, preparation, consumption, and then down here again, more preparation, consumption. If you're going to a restaurant meal, or in our case, we had a sandwich brought in. Each of the components come from different sources, and all of them follow a different supply chain as we trace them backwards. So this is not a simple, like there's one trucking company, there's one food distribution company. There's hundreds. And as we go back up the chain, it's just this crazy multiplier effect. It's amazing we ever find who infected us with food. We do, but it's actually amazing because most people don't even know. So when we're investigating a foodborne illness, we trace our way back up that chain. And when we find the source of the infection or the contamination within the supply chain, we want to mitigate the contamination. We want to say that anything's inside of the current chain up from there. So we find a contamination here. We want to say everything that's this way, we discard. Right? So we do a product recall or something like that. We try to tell the consumer, don't eat that. It's labeled blah, blah, blah. Don't do it. Maybe you'll get sick. Maybe you'll die. Who knows? So that's an important thing. Now, I'm bringing it back to what we think about with software and what we think about with latitude. So what does it have to do with it? Like this picture of contagion. Right? I don't know why. I wanted to get a really gross picture, but I thought work inappropriate. I love that movie for some reason. So much like getting sick from a meal at a restaurant, being exposed to software defects, which we all are, can have devastating consequences. We don't often think about it for those of us that write software, those of us that consume it, but can actually have devastating consequences. Not in all cases, but in some. So like a restaurant meal, created software itself, and for most that don't know this, has its own supply chain that's full of risks. Right? If you use quote-unquote open source software, okay, that's just software created by a bunch of people. What's the quality of the software? Well, I don't know, right? How many people in this room cared where the sandwich came from? You're just like, oh, I'm going to eat that sandwich, right? So open source software, we think about this. Where did it come from? Consumers of software are similarly seldom aware of how software has impacted their lives negatively. So for example, unless you've actually experienced identity theft that you can directly correlate to something that occurred in a software package that you're using, you might not make any causal relationship. You're just like, oh, my identity was stolen, right? Maybe it was because of that PayPal transaction you just did, right? Or what was the one they just shut down? Ashley Madison, right. I heard of it too. Okay, so we want to think. We're always thinking. So quick break. What do you see? Just a little visual break here for a minute because I got to drink some coffee.
It's a tool video?
Is it spinning?
I see it. When I look to the side, it looks like it's spinning a little bit.
Those are the mushrooms?
Okay, is it spinning or not spinning? Okay, let's do a vote. I don't know. I can't tell. So let's do this. Who thinks it's spinning? Hands up. Yeah, it's the same thing. It looks like it's spinning. You think it's spinning. Who thinks it's spinning? Okay, who thinks it's not spinning?
It's moving, but it's not spinning.
Okay, who thinks it's moving? I'll be more. Okay. So this is an interesting one. It depends on, there's like lots of variables when you look at things like this, right? Like, your perception of color. We all have a different perception of color. But the majority of people actually, when you see this at a smaller scale, I didn't test it on the presentation before I brought it, but I'll share it with the team after. And actually, most people perceive this as spinning in this direction. What would that be, clockwise, I think? And it's actually interesting because it's just a strange, artifact of the way our eyes process information. It's just funny, but it's not moving. So anyone who saw it moving, it's not moving, right? But you probably guessed that. But it matters. So what do you see? Who sees movement? Neil, what if I told you that there is no movement? Who can see the movement? And the other interesting thing is, once you start to see the movement, who can actually stop seeing the movement? Right? It's interesting. The movement I also found when I was experimenting doing the presentation dramatically changes depending on your optical distance, how far you are away from the presentation. So that's why I probably should have experimented in this room on the optimal size, right? But it is interesting that it's hard to stop seeing something once you've seen it. So for those not in the IT field, here are a few famous software bugs and defects. In 1985 to 1987, in Canada, there was a radiation therapy device, the Therac 25. Nice little device, not exactly consumer grade, but not experimental. It was sold off to hospitals and independent people. So what ended up happening, though, is they had a little bit of buggy software that was powering another device. Number of patients that received up to 100 times the intended dose of radiation. So they were going in for essentially a version of cancer treatment, right? They're getting localized radiation on them. And people were being burnt. And 3 people were burned to death because of a software bug, right? So imagine, you've got cancer and you go in and you go to get your treatment and, you're done. You're barbecued, right? Terrible, terrible thing. And the hardest part about something like these kinds of systems is, again, it's hard to know what is the root cause. For those of you that have hunted bugs in software, is it hardware? Is it software? Is it something the user did? Who wants to lay on the table while we retry this? Probably nobody, right? So it's kind of an interesting thing to try to replicate. So that's a good example of something that when I was talking about bugs that are serious with big consequences, that's a good example because for most of us, life and death, that's probably one of the more important things we worry about. Right? Other than that, everything's kind of like, not as bad as death, Can't say I didn't experience that. Here we go. How much quality can $7 billion buy you? Let's see. Oh, it can buy you that much. Hold on. It's such a good video, I just want to show it. I don't know if we get audio, though. So the audio doesn't really matter. All these guys are essentially saying is, count off to lift off, here we go, we're ready to go. Of course, it's in another language, so fine. Here we go. So what we have here is European Space, what is it? The European Space Agency. So this was one of their large projects. Up until this point, here's their launch of their rocket that's essentially going to take all of their scientific instruments and things into space. It's about $7 billion they've spent on the project so far. A lot of money, 10 man-years worth of time spent on this project. And up it goes. Oh, it's going to go all the way to the moon, don't worry. No, I'm just kidding. I'm just teasing you guys. Let's see what happens. Does it go all the way or not? Uh-oh. 10 years of a team's life gone in, well, I put down here 1 minute, 45 seconds. It was less than a minute in the air, okay? So what does that tell us? I can just skip past here because I think the rest of this is just more falling pieces. Oh, no, I'll show it. Oh, I won't show it now. Okay, so 10 years of work, $7 billion, 39 seconds into the flight, a piece of code. Now this is interesting. They did a root cause analysis on this. Okay, so most of us know what happened in the Challenger disaster way back in the 80s. It's a well-understood problem of engineering and this. This was such an interesting one. So for $7 billion, the root cause of the issue was that a piece of software that should not have been running. It didn't need to be running at the time, was running. Essentially what it was a bunch of developers got together with the engineers and they said, you know what happens if we're on the launch pad and we get delayed? And the guy's like, oh, crap, that happens a lot, right? You know, they're about to launch and something comes up, and so they pause the launch. So what they decided in this case is they said, well, there's a window of about 40 seconds. And in that 40-second window, as long as we pause in here, then we can just restart the launch count, and away we go. So what happened in this case was they essentially said there was no pause, so they went through and the launch went, but about 40 seconds later, this piece of code essentially looped, right? Yes, sir?
They actually noticed the error. They had a meeting.
Before. Okay.
And at the end of the meeting, they didn't follow up with anything. They didn't have action items. So the lesson is use judgment.
I fully support that, because actually before the Challenger disaster, one of the lead engineers also said we shouldn't launch right now because of cold, and they said no, we're going to launch anyways. So in this case, what it was, the root cause, all it was a conversion from a 64-bit number to a 16-bit number. That's all it was. That's what caused all of the damage. So it's, again, interesting. There's a deep dive on the bug you can look up on yourself, long story and stuff. Great engineering problem. So one more just because of the cost. Cost up to $500 billion worth of people's time translated into money. So down here, Y2K 1999, $500 billion, or about $7 for every person on the planet. Disaster. One man's disaster is another man's fortune, as demonstrated by the infamous Y2K bug. Businesses spent billions on programmers to fix a glitch in legacy software. Interesting, isn't it? So well-known significant computer failures occurred. Preparation for the Y2K bug had a significant cost and time impact on all the industries that were using computer technology. Okay, so cause. To save computer storage space, most of you know this, but I'll just, for those of you that haven't done a deep dive on Y2K, Unix, we love you. Okay, legacy software often stored dates as a 2-digit field, right? And then when you turn the century, you essentially had calendar rollover, and that was kind of the big fear, is you went from 1999 by assuming the last 2 digits were 99, and then 00 now could mean 1900 and not 2000. Okay, so it depends on whatever software is built on the assumptions. So everyone all got freaked out, and lots of people, and the good thing about it was there's a lot of IT jobs from like 95 to 99, right? Because everyone's like, oh my God, what might happen? Well, who knows? So, and I wrote upside down just so you'd all have some fun reading it. So when the year 2000 came along, bugs would result. Right, here's this Weekly World News headline, the day the earth stood still. There's great headlines all about it. Like everyone was, you know, kind of scared and kind of laughing, but you're kind of like, will the nuclear reactors blow? Maybe, you know? But I'm going to get drunk, so let's go, you know? Okay, so we're going to come back now. So quality assurance is not a job. Let's start there. QA, quality assurance, QA meaning quality assurance, is not a job. It's very important, right? It's like software development, software engineering is not a job. Some people call it a job, but it's a field of knowledge, right? It's a large body of knowledge. And quality assurance is very similar. So like all fields of engineering, our goal is to learn from our failures, which is why I showed the examples of these really expensive failures, and to pass knowledge, learn from those failures onto those who are continuing to build new projects. That is really the basis of all engineering. We're going to build stuff that breaks. We hope not, but if it breaks, we're going to figure out why it broke, and we won't do it that way again. It'll break in a new way. That's what engineers do, right? You know, and over 100 years with construction, we're getting pretty good at many things not falling down. Not perfect, right? Software is relatively in its infancy relative to most other engineering fields. So we'll see what happens, right? We're all working, that's why software engineering is a specialty, right? It's a body of knowledge in its own right. That's why we talk about these things, is we hope that our software, like buildings, don't fall down. So this is why we have a field of learning, a subset of engineering thinking devoted to this concept of quality. Interestingly enough, it's one of the 10 knowledge areas identified by the Project Management Institute. So when the PMI decided they were going to try to figure out how do we cluster all these things that make up successful projects, they said one of the things that is important is quality and what that means. So at Latitude, like all successful software companies, there are individuals and together teams who focus their work on helping to improve the quality of the products. All right, so what do you see? Movement or no movement?
Big movement.
Big movement? Okay, hands up if you see movement in this one. Okay? So again, I want you to look at this and just realize that nothing is moving. Okay, it looks like an animated GIF, but it's not. Nothing is moving. It's crazy, because you're like, how can nothing be moving? It's moving. But it's not. But it is. But it's not. So when we talk about it, we have to ask ourselves a question, and we should ask ourselves, and this is why I used that Neo thing earlier, about the matrix, is when we're looking at problems, it's really easy to see problems from our own perspective only. That's human. It's natural, right? But part of our obligation is to see things from other people's perspectives. And once we can do that, once we can put on, for example, the customer hat, as a good example of perception, it allows us to see the problem in a different way and maybe unblock our thinking that's wrong in the other. So what value might more testing bring? A 2002 study commissioned by the National Institute of Standards and Technology in the US, I have a link, you can refer to it there, I'm not making this up myself out of whole cloth, found that software bugs cost the US economy about $60 billion every year. It's a lot of money just for bugs. 60 bill. It's a lot. Okay, the study estimated that more than a third of that amount, about 22 billion, could be eliminated by improved testing. Pretty good estimate. Save 30% on your costs by reducing defects, by reducing bugs. And this is the essence. This might sound new to a lot of people in software, right? But this is the key for all manufacturing industries, is they're always asking themselves, how can we do this better? How can we do this smarter? Software, the reason it's a bit tricky is sometimes it feels like everything we're doing is new and original. Sometimes, right? But there are lots of people who are smart enough to write books on patterns, anti-patterns, right? We try to codify our knowledge in a way that's accessible to people quickly, that they can get it, they can grok it. For those who don't know the word grok, they can get it. So at a high level, software quality assurance. So I like this little yin and yang symbol because I like the yin and yang symbol, and if it has words on it, I'm like, yeah, awesome. Okay? But I like it because it does give us this balanced aspect of what is quality assurance. Most people think quality assurance, in general, is about testing, right? We're going to test it. Did you test it? Is it tested? Tested. I don't know. Is it tested? Testing. Part of it is detection, right? So we use testing around everything that we do in life to validate. So is a property there or not? Does it behave the way we expect it or not? It's often binary. It doesn't have to be, but it's usually we frame the questions in a way that it's easy to interpret the answers. Quality assurance, though, in the bigger picture, is also about prevention. So we're talking about quality assurance. What we're really talking about isn't just, can I detect the error? But it's like, can I detect it as early as I can after it was introduced into the system? That's really the key. That's the ultimate goal of this portion of it. So testing gives us some data, which is interesting. Quality assurance then takes this data and it says, what are we doing that created the issue? Why is it there? Why do we have that bug? Is the bug because someone accidentally typed it? Is it because someone made a bad commit? Is it because the guy who did the commit quit the next day? Right? And no one went back to check if the guy who quit actually just wiped out your whole code base by injecting errors? Happens. Right? We don't often happen, but if you don't want a good reference and you're changing fields, you might do something stupid. Okay? So one of the things we always want to do when we're talking about cost. Okay? So we're in a company, we're in a business. We had a nice presentation this morning on the numbers. Right? Selling is part of the equation. It's an important part. The other part of it is costs in business. How do we keep our costs down? Right? And that was that one slide where we saw the lines coming of the staffing numbers going up and our profit kind of remaining stable, right? But some of our number of every employee, it wasn't actually a causal relationship as was explained, but it's the idea that as we are adding employees, we're adding costs to our overall operation. And then we want to ask them, so what does that mean? Right? When we're talking about quality, we want to make sure that we catch defects early for a bunch of reasons. These are just a few that I randomly wrote down. Because the sooner you find it, the cheaper it is to fix it. That's probably the number one reason people always say, right? So here's your little graph here from the Applied Software Measurement by Capper-Jones. Now this is such a fantastic graph because it says what I want you to believe, all right? Which is essentially earlier in the development process here. These are costs associated to when you find defects in your software. It's a commonly understood thing by people who develop software, which is the cheaper you find a bug, generally, the cheaper it is to fix it. And if you think about it from this perspective, if I write a piece of code, and then I hand it to you, and you do a bunch of work assuming that is good, and then you hand it off, and you do some work, and you assume it's good, and then it goes off outside of development, it goes into, let's say, our marketing department. The marketing department's like, oh, fantastic. They finally saved the world with the software. And they go out and they tell the whole world about this. And then I'm like sheepishly going, oh, actually, no, it doesn't work. Right? It's a defect. Maybe there's a defect, or I solved the wrong problem, or I solved it incorrectly. So the earlier we find it, the cheaper. This is kind of an interesting one that most people don't actually understand, unless you've been around the block a few times, which is the odds of you fixing it before someone else gives you something else to do are better. Right? So I find a bug today, and I'm like, oh, I'll work on it tomorrow. And then tomorrow comes, and somebody's like, oh, I got this really important thing to do. Right? So you go, let's put it in the backlog. Into the backlog, which sometimes can become this giant, black hole. Right? Because you're like, oh, I should have done that. But other things got in the way. So when it comes to bugs and defects, that's why we want to approach defects, particularly in software, as soon as we can. Because the odds of them getting fixed are actually much higher, especially high priority bugs. Now the other thing which is interesting is the fewer people it will impact and the smaller the impact multiplier effect is. So I've already kind of spoken about that, which is once I hand off my piece of work to someone else and they build on it, there's this weird multiplier effect, and it's not linear. Like it's not like, it cost me $10 to do a piece of software and then I give it to you and you're going to put $10 of effort, now it's $20 we've spent. Right? There's usually this weird multiplier effect in software. And the feedback chain is actually even more expensive because communication amongst humans is really hard. Oh, really? It's broken. Oh, it is. How is it broken? Well, let's have a meeting, right? And then you go off and you have a meeting, and then you invite a bunch of other people in, and then the stakeholders come in, and the next thing you know, they're expensive, right? So we want to, as early as possible in the process, make sure we are solving the right problem and that we're solving the problem right. Both of those things together is what we're always trying to balance. Okay, so which person is longer? Which one's taller? The top person or the bottom person? Okay, if you think the top person is taller, put up your hand. Okay, if you think the bottom person is taller, put up your hand. If you think they are exactly the same, put up your hand. Okay, so again, measurement. Which of the two men is taller and by what percentage? I tricked you by asking you that other question. By what percentage? Because right away you're like, well, of course they're different. What percentage? 12, 15? You actually didn't even think, no, they're not different, except for some people who are like, oh, this is crazy, I'm not doing this. Okay? So for defects, we consider many things, including, and I always harp about this, we always want to talk about both severity and urgency. They're two different things. We lump them together to talk about priority, but really we're talking about two different things. And then we use those two things to help us prioritize defects, because there's multiple stakeholders when it comes to software defects. The other thing to remember when we're talking about software defects in particular, that's different than features, it even came up in our meeting we just had, which is the fact that bugs are evaluated in the current context. Okay, features are not. Like, they kind of are, but like features, you're like, you know what, we're going to do this for the next 4 months. Yeah, that's a good plan. We're all going to work together for this goal. When it comes to bugs, they come in and you evaluate them in their current context, but then something else comes in. And now you have to reprioritize them based on those two things. Because there's no perfect objective measure for bugs. Right? It depends. Like if I have a low priority bug that affects 1 million people, maybe I'll fix it. If I have a high priority bug that affects one person and they don't pay me very much, maybe I won't fix it. right? I mean, that's the Microsoft model. They didn't fix anything in all those years. I was so mad. You know, open office sucks. Okay, so the question is, why are these two guys on a railway track? That's really the question. So what does a software quality assurance team member do? So what they try to do is they try to validate what is the front of the cube. So where's the front? No. Quiet room, okay? So the QA team work with the development team to help see the problems from different perspectives. That's one of the things that they do. They're involved shortly after the creation of the idea. So in our lingo, after a story is validated and prioritized by the product owner. They might be involved earlier, but definitely as soon as we have an idea and we say, look, this is a great idea, fantastic. And then we also can have a sense of where we're going to do this work. Immediately want to get someone with that quality assurance hat on, looking at the problem, right? You want to get people involved as soon as it's important for them to be involved. We always talk about that. So they help to define the limits of the solution, which is also important, by writing test cases. That should produce the expected result. For example, they should pass a test case. The artifacts of their work become records of the previous state of ever-changing software. So it's also a nice little side effect there is we had a bug. We experienced this upstairs in software just the other day, 3 weeks ago actually, but in August. But essentially, we're sitting there on August 4th and we're testing some software and like, it's broken. And it's like, no, it's not broken. It's broken. It's not. I tested it. Okay, well, it's broken right now. When did it work last? Well, luckily we actually have a tool, a product where we record our test results. So we can just go back and go, oh, well, I know it worked on July 31st. What are the commits that happened after that date? So it narrowed the problem down from 4 months or 3 months to about a 6-day window. So we didn't have to go hunting for exactly who broke it or why it broke. We at least had a good clue. Right? So again, that's one of the things, one of the values that you might get from quality assurance. So I'm confused. What is a QA person? I've just talked now for 35 minutes. What is QA? So I think one of the things we could talk about without changing the moniker QA is really you want to think about a quality assurance person as a quality analyst. Right? That's probably a better definition for the role. Quality assurance is the large body of knowledge that you're talking about. And quality analyst is a person who completes the work associated with a process improvement and with defect detection in the product. So in a similar way, we have business analysts. You have quality analysts. That's the hat that they wear. Inside of that, they often do a bunch of different tasks or they have different roles. That's kind of another way. So if you're thinking about QA, you can think about it as quality assurance, as a body of knowledge, or a quality analyst as a person. That person is in QA. That sentence doesn't make any sense to me. Like, it's always hard because it is a body of group of people, but it should have like another letter at the end. So, okay, I'm going to skip the rest on that. But in a similar fashion, I just want to kind of draw this back. So an astronomer focuses on the knowledge area of astronomy. That's what an astronomer is. You don't say, hey, that person's astronomy. Right? Oh, astronomy. No. That person's an astronomer. And astronomy is their body of knowledge that they're interested in or working different thing. And it's the same with quality analyst, focuses on the product and system quality. So bring it back, last slide. Quality assurance is a large body of knowledge derived primarily from experience. It's made up of knowledge, which we can talk about, concepts and things, and it's also made up of things we would call best practices. So best practices, like in most fields of engineering, you want to apply them when it applies. So you don't always apply them, it just, when it applies in a particular circumstance, use the best practice. Don't invent things unless you're better or smarter. Great, then you can make the next best practice. But until then, use the best practice. Quality analyst is a role, like a business analyst. The role has responsibilities related to guiding the products toward ever higher quality outcomes. That's kind of their what. That's their why. Not their what, that's their why. Right? In our working style, the role is embedded, integrated within the product development processes. But this is the kind of the key for the overall presentation. That's, remember that even with people directly focusing on the work, quality in our product is a direct result of the work that we each do. That is probably the key takeaway from this presentation when it comes to quality. right? Or assuring quality, or whatever. And that's that at whatever point you decide to interact with the marketplace. So if you're customer facing and you're talking to customers, right? Or the creation of a product, you're changing, and this is interesting with software, you're changing the expectations of others. You're talking to them. And they're like, are you going to fix it or not fix it? And while you're talking to them, in their mind, even though you can't see it, right, they're changing their perception of what they think the value is of the thing that they bought. Did I pay too much or not enough? Am I getting a deal, right? That's about value hidden. And a lot of that is that thing that grows over time. That's the thing that we're trying to nurture with our customers, is so they understand our company and their needs are in alignment. We want to do the best for them because it's in our best interest as well as theirs, right? And those are things we want to make sure we're always communicating. The other last point here, the perception of quality of our offerings by the marketplace, its value is entirely subjective. True for all software. Is Mac better than a no-name laptop, like, your Office Mac? The perception is yes. Is it better? Nobody ever really measures anything, right? Am I going to spend 1.5 times more for a Mac? Probably. Why? Because I'm an idiot. Is it better? Maybe. It depends. If you're old and you've watched, Mac and Apple, Apple as the corporation, but you've watched, the Mac family over time, you're like, these guys are idiots. They had a great idea and a great product and great engineering, and they built it, and the market didn't want it, and somehow they survived, and Microsoft bailed them out, and it's this crazy story, and now they're winners. But again, it comes back to this idea of perception. Now everyone's like, Apple's awesome, best company ever. I wish I could work at Apple. This was not the case 12 years ago. 12 years ago, everyone's like, I got to dump this stock because they suck. So perception. So back to perception. Which of these red dots is bigger? What do you perceive to be the bigger red dot? Not what do you think is better, but what do you perceive is the bigger red dot? Okay? So if you think it's the one in the top left, put up your hand. Okay? Top right, put up your hand. Bottom right or bottom center, put up your hand. Okay? So, of course, this is confusing, but they're all the same size. All the red dots are the same size. And this is the thing about human perception, and we're talking about quality or qualities, right? Based on the context in which we're looking at a problem will affect how we perceive the thing. So when we're thinking about a bug, or we're thinking about defects in software, or we're considering what our customers think about it, this is a good reminder about perception and why we're really ultimately playing with a version of reality, which is broken code. But on top of that, there's a whole thing about expectations and perception, and everybody at that layer sees the problems quite differently. So the goal for us as a company, when we're thinking about quality and we're thinking about communicating quality and we're talking about processes and everything, the reason we do all of those things ultimately is to make that mind connection with the customer, that they understand that the things that we're doing are for exactly that purpose. It's to make the product better. We want to communicate that. We want to find common language and lingo that does that. So that's why a presentation like this may or may not have value, but at least as a company we understand what is another way to talk about software quality assurance and why it matters and why we put money and resources on that. Because as a company, we think it matters. So I'm right at the time limit where I said I'd be done, except for question and answer. So let's do this. Let's do exactly 2 questions. If there are no 2 questions, then we're done. So question 1, go.
Do we have any formalized process for tracking and managing our supply chain bugs?
I have no idea. Can someone answer that question? That's a good question. So,
define supply chain.
yeah.
Cassandra.
Yeah. That's great. It's a fantastic question. So what do we think?
Yeah, it's a yes or no question, so I'll answer yes.
Okay.
Because I didn't know if it was just the people that are haven't been using that software directly as a library, are the ones that would notice it, as opposed to looking at the release notes and bugs fixed.
We don't expose that, but Jira issues have a cause field. When you're fixing the issue, you can say what caused exhaust that issue, and so then we can do jurisdiction filters to say, what were all the issues caused by X or that are, but it's loose, it's not really.
Yeah.
So I guess there could be something where there's an issue in a particular version of software that we use that doesn't cause any bugs in our software, but would be a resultant bug or
I see what you're saying.
some sort of security hole, but we don't, because it's not our software, we don't necessarily track it.
Okay, we don't track that.
Yeah, but we should. Because if we're thinking from the perception of risk management, because that's really what it is. You're like, if you're using somebody's services, we call them products or services, and they're going out of business, you may not get any more support, but you've just built your whole platform on them. So you tag it as a risk, and then you decide if we're going to do something about it based on reality. So maybe we should track that. Okay. Next question. Number 2 of 2, if any. Yes.
You described the quality assurance process as kind of an asymptotic thing, always trying to reach for the ideal.
Yes.
There are always going to be defects.
Yes.
Over your experience, maybe in Latitude or even before, what is like an acceptable defect rate in software?
There's no such thing. The acceptable defect rate is what the customer is willing to accept. Because when the customer stops accepting that defect rate, you're done. They won't buy. And when they stop buying, you run out of money to bill it, ultimately. I mean, there's other objective measures. Like you always want to be striving for better, but you're always putting your development efforts in context. So, for example, everybody's moving their products online right now. Not everybody, but lots of people are moving them online. This is just another example of software evolution. We've had this before. And the question from the company's perspective, when we're thinking about like Microsoft Office, which we just translated to, not all of the features that I use for the PowerPoint presentation here are in the online version of PowerPoint. There's more in the offline version. Microsoft is trying to figure out how are we going to survive as a software company when Google is offering Office-like products for free, good Office-like products for free. Can they continue to use their old model versus their new model? So those are kind of questions, like we talk about, like, back to defect rate. It really is that ultimate question of trade-offs, right? Your software always has to be good enough. And good enough is whatever the customer says it is. That doesn't mean it's good or great, that's not the objective measure behind the scenes. I'm like most people here, I'm obsessive compulsive and I love writing great things. I love writing good code. I like solving problems. I'm crazy, okay? But I also put that in the perspective of the reality of the marketplace, which is if I produce absolutely the best product, but nobody wants it, that's okay if I don't care about revenue. Like if I don't care about selling it, I've just built the best new, how many programming languages are there? A gajillion? It's an exaggeration, but there's a lot of programming languages that nobody uses, but they're better, but nobody uses them, right? Why? So this is kind of back to the question, when we think about that, those are the deep dive questions that you'll ask your whole career, right? You'll see software succeed and software fail. You'll see crap stuff succeed, and you'll be like, why? How did that piece of crap just make $1 gajillion for that company, right? Or companies that are offering services and they're not charging any customers. What's their source of revenue? Maybe it looks like a great business model until their investors pull all their funding and they're out of business. So they're deep questions that you'll ask your whole career, and this is just one aspect of the knowledge that we talk about, one of the knowledge areas that will impact all of the decisions. So that's it for a second question. If you have other questions after, just to respect the time, you can email me if you like, or just come up to my office and chat, and have fun. Have a good rest of your day.